Hello again. Thanks for watching this video and studying your math. This video talks about radical expressions. We'll talk about the notation, how to simplify them, operations we can do with them, including a new operation called rationalizing the denominators. As always, reading your book is important because there are different examples in your book than the ones I go through, and you should start and stop these videos as you're watching it to make sure you understand the material. Previously, we used rational exponents to express roots. This is an alternative notation. The number that is in the little check mark nest is called the index. The red symbol is called the radical symbol, and what is underneath the radical symbol is called the radicand. And the definition is when we write the nth root of a, that means the same thing as a to the 1 over n. Likewise, we can talk about a to the m over n. That means either the nth root of a whole to the m power or the nth root of a to the m, either one. Whenever we don't write a number here, it is assumed to be 2. So that means for even values of n, square roots, fourth roots, and so on, when n is positive, there are 2 nth roots. One is positive. This symbol is called the principal nth root, and for n even, that is always considered to be positive, or minus the nth root of n, which represents the negative root. Here's a classroom example. We're to write each root using exponents and evaluate. Let's pause the video, see how you do. In this problem especially, note that there is no real number such that you can raise it to the 4th power and get a negative 81. Therefore, the answer to that is not real. This classroom example, we're to convert rational exponents into radicals. Let's see how you do. And here are the answers you would like to come up with. Example 3, we're converting radicals to rational exponents, and we want to write these in exponential form and simplify. Let's see how you did. This is a caveat. This is a common mistake students sometimes make. You can try numbers to figure out that this is not true, numbers for x and y. Another mistake that students often make is they think that the square root of a squared is a. It's not. It's the absolute value of a. Consider a to be minus 6. Minus 6 whole squared is going to be 36. The principal square root of 36 is going to be 6. So you see, instead of being minus 6, it's the absolute value of minus 6. This is only an issue when a is even, and so it makes a difference if you are even or odd. Here we're using absolute values to simplify these roots. Note here is an example similar to what I said. So you get the absolute value of minus 3, which is 3 as the answer. When working with variable radicands, we usually assume all variables represent only non-negative real numbers. And in fact, these rules are not true with complex numbers. We'll talk about those later. But these are the power rules that we studied in exponents translated into radicals. Make sure you understand these. Make sure also you understand what it means for a radical to be simplified, because often the directions will say simplify completely. Note especially that we do not have radicals in the denominator. So here we're to simplify all of these expressions. Let's see how you do. This problem could have also said that 8 is 2 cubed, and so this could also have been the 4th root of 2. as an answer. Here we're again to simplify each radicand. Ask questions either in the guided study group, class, or in the Learning Commons, or find the answers somewhere to make sure you're good with all of this. We can only combine like radicals, just like those make them like terms. And radicals are alike when they have the same radicand and the same index. That's the only time you can combine them. Example 7 deals with that. Please give this a go and we'll see how you did. And these are the answers that you should have come up with. Another simplifying of radicals. And these are the answers that you should come up with. Here we're doing some multiplying. Notice that this first one is the form a plus b times a minus b, so the middle terms are going to cancel out, and you will get a rational number for that answer. Going back to the simplification model, we are looking to rationalize denominators. That means we have to multiply by some form of 1 to make that happen. Here are 2 problems that you should give a go. Let's see how you did. Here you multiply by root 7 over root 7 and simplify. Down here you have the cube root of 3 squared. You would like it to be the cube root of 3 cubed to make it into a 3, so you multiply top and bottom by the cube root of 3 and simplify your answer. Another simplification, this time with fractions. And these are the answers that you should get. Previously we looked at taking something that looked like this, a minus b times a plus b, and it equaled a rational number. So if we find a denominator that is a binomial, has 2 terms, in which one or both of the terms is a square root radical, we can multiply top and bottom by what's called the conjugate. The expressions a minus b and a plus b are conjugates. Here's an example of that. Rationalizing the denominator. So we multiply top and bottom by the conjugate of the denominator and simplify, and that's the answer you should have gotten at the end. In closing, time is precious. Each day must count. Do the math. It will make you strong. Take care and see you in class.